Okay, the last part of integration technique is actually integration by parts. Okay, integration by parts, some school actually use, there are two formulas that are floating around in Singapore. Okay, but generally, most school are doing this formula. Okay, if your school uses the other formula, doesn't matter. It's actually the same thing. It's just different way of presenting it. Okay, so integrate of u dv dx is equal to uv minus integrate of v du dx. Okay, integration by parts is generally my last resort. Okay, I call it the last resort. Basically, is any other formulas that you really can't use really, then you think about by parts. Okay, if not, you go through from type 1 all the way to type 7, then you think about by parts. Okay, so by parts is generally always my last resort. Okay, so very simple. Okay, this is just a general rule of thumb. Okay, which one do we use as u, which one do I use as dvdx? Okay, so we're going to go down the list. Okay, the first one, the top first will be u, followed by dvdx. Okay, so same thing, bypass formula is not in MF26, so please go ahead and memorize it. Okay, you have to memorize it, unfortunately. Okay, if not, you won't be able to use the formula. Okay, so very simple. Let's take a look at this example here. We're going to learn through different kind of examples. Okay, so what happens is that you realize that you have two parts. One is x, the other one is cosine x. Okay, so if you go down the list, okay, algebra will come before trigo, which means that okay, your u here will then be equal to x, dv over dx will then be equal to cosine x. Okay, if you look at the formula, I need to have du dx, same thing, I have to have v. So I need to differentiate here to give me 1. Okay, I need to integrate here to give me sine x. Okay, so how the formula works is very simple. Okay, uv, so it's x sine x, minus integrate of v du dx, so it's v sine x times 1. Okay, x sine x, okay, remains. Integral of sine x is equal to minus cosine x, so it will be plus cosine x plus c. Okay, this is my formula over here. Okay, so same thing, the formula which require you to differentiate the u and integrate the dv dx. Okay, going to run through the next two example. Okay, take note, x squared ex. Okay, you can go ahead and try it. Okay, so basically a hint for you is that you have to do integration by parts twice. Okay, so I'm going to leave it to you to try. Okay, so which means that you do by parts already once, then after you have to do by parts again. Okay, I can run through the example with you very quickly. So integrate of x squared ex dx. Okay, I'm going to quickly identify my u as my x squared. Okay, algebra come before exponential, so dv dx is actually equal to ex. Okay, du dx will then be 2x, and integrate of ex will still remain as ex. Okay, so a quick one, I'll get x squared uv ex minus integral of v du dx, so it's 2x times ex. Okay, unfortunately you still can't integrate because of the 2x in front. Okay, so I'm going to do by parts one more time. So in this case, your u now is 2x, your du dx is equal to 2, your dv dx will still be ex, okay, your v will still be ex. Okay, so I'm going to write down the formula, x squared ex, okay, minus, okay, put a big bracket sign, if not you're going to get careless mistake. Okay, uv, so it's 2x ex minus integral of v du dx, so it'll be 2 times ex dx. Okay, so expand out the bracket, sorry, okay, plus integral of 2ex will then be, this will be plus 2ex plus c. Okay, take off the bracket so you don't get a careless mistake on the negative sign. Okay, next one we're going to talk about is part 2 integral of sine square x. Okay, I'm just going to give you a hint. Okay, your u will be equal to x, dv dx is equal to sine square. Okay, then go ahead and do your answer should be, okay, I'm just going to write answer here, x squared over 4 minus sine 2x over 2 minus cosine 2x over 4 plus c. Okay, so you have to go and use the cosine square formula to learn how to integrate sine square x. Okay, the next two parts is actually, I call this the interesting by parts question. Okay, I'm going to show you why. Okay, I'm going to run through the step. Okay, you can actually pause the video here and go ahead and try first. Okay, if not, I'm just going to quickly run through with you. Okay, so integrate of ex sine x dx. Okay, this is the first formula. Okay, I'm going to write here. Okay, same thing, my u will be equal to sine x. Du dx will then be cosine x. Okay, my dv dx is actually equal to ex. My v will then be equal to ex. Okay, so if you quickly write out the formula, it should give you ex sine x uv minus integrate of v du dx. So it will be ex cosine x. Okay, realize that I still cannot integrate ex cosine x. So what I'm going to do is I'm going to do by parts one more time. So my u will be cosine x. Okay, du dx will then be negative sine x. Okay, my dv dx is equal to ex. My v is also equal to ex. Okay, same logic. Okay, so it's going to be ex sine x minus, okay, same thing, put in the big bracket sign. Okay, uv, so it will be ex cosine x minus integrate of v du dx. Ex times negative sine x. Okay, realize that, hey, I'm sort of stuck in a loop. Okay, which means that I cannot keep going on a differentiate because sine and cosine will just take turns to come out. Okay, what I'm going to do is, okay, I'm going to rewrite the entire equation here so you can take a quick look and perhaps understand. So integral of ex sine x, okay, essentially we will derive to all this part over here. Minus integral of ex sine x. Okay, you should see that, okay, seems like these two are the same. So same as your manipulation, I'm going to bring to the right hand side. So it becomes 2 ex sine x dx. Okay, essentially, okay, is this. And hey, the question actually want me to do this. The question only want this. So what I'm going to do is I'm just going to divide the entire equation by half. And that will essentially derive the answer. Okay, but do remember to put a plus c. Okay, part 2 is quite interesting question. Okay, so basically I'm just going to run through with you. Part 2 is integrate of tangent inverse x dx. Okay, we only learn how to differentiate tangent inverse. We never learn how to integrate tangent inverse. So how, when you see a tangent inverse or you see a ln, okay, or things that you cannot differentiate or cannot integrate straight, okay, but you can actually differentiate very easily, I will do this. Okay, I will introduce a 1, okay, so that it doesn't affect the formula. So how do I do this? Basically my u will then be equal to tangent inverse x here. So du dx will then be 1 over, okay, your formula will be 1 plus x squared. Okay, so my dv dx will then be equal to your 1, v is equal to x. So basically I introduce a variable for me to integrate so that I can differentiate tangent inverse very easily. Okay, so this will give me uv, which is x tangent inverse, okay, minus integral of v du dx. So it will be x over 1 plus x squared. Okay, you can realize that the second one is actually using an f prime x over fx formula. Okay, so what I'm going to do is I'm just going to quickly write down. Okay, I need a half outside, so I have a 2x. Okay, so this will give me minus half ln bracket 1 plus x squared. Since it's always positive, my final answer to be here. Okay, so we have completed the entire integration. Kindly go and do out your tutorial if you are relearning this entire topic. Okay, if you are just forgetting bits and pieces, then it's okay. But I will generally ask you to get and complete our tutorial since that's all we actually learn for integration techniques. Okay, if not, I will see you in the next topic if that's all for integration technique. Okay, the last page is actually a quick summary so you can actually take a look at whatever we went through so far.